Hi, this is a lesson on quantitative univariate graphs for our statistics class. So today we're going to be using a graphing calculator. So if you do not have a graphing calculator with you at this moment, I would like for you to pause the video and come back with one. Okay, great. So on this slide, I have an example of what we would call quantitative data. So quantitative data is data that represents quantities or amounts. And the data that I have in front of you are the ages of Academy Award winning actresses at the time that they won the Oscar for Best Actress, or like Best Leading Actress. And so we have here the two actresses. Not at the ages that they won the awards that we're talking about, but this is the person who won the award as the youngest person, and this is the person who won the award at the oldest age. This is not, this is a picture of her as a young person, but when she was the oldest. And so I wonder if you know either of their names. This is Katharine Hepburn, and she won the Oscar for On Golden Pond. And this actress I had to look up. Her name is Marlee Matlin, and she was only 21 when she won her Oscar. So just a little bit of trivia for you. Here's our data set. And so what I'd like us to do is to take this quantitative data, and it's again quantitative because each of these is a quantity. 50, for example, is an age, but it is an amount of years. So that's what makes it quantitative data. So I'd like you to take this quantitative data and put it into your calculator. So on our next slide, I have the data again. And so this is just maybe a little bit easier to read, more in the middle of the screen. And what I'd like you to do is to take your graphing calculator, and on my graphing calculator, the place where I'm going to go to enter data is called statistics. So in the stat menu, I'm going to push enter. And you see, I find that my calculator already has some old data in it. So if that's you, you're going to go to the heading on the list and type clear, and then it's going to look like nothing happened, but then hit enter and it will be cleared out. Now make sure that you use clear rather than delete. Delete deletes the list from existence, and that is not something that we typically care to do. Okay, so I'm going to again show the slide that has the data on it, and I would like you to pause the video and type in the data and then come back when you have all of this data in your calculator. Now, before we go to that, actually, should this be 3 lists? Should this be like 12 lists? I mean, it isn't a grid, right? So is it all one list? Is it multiple lists? The answer to that should be it's all one list, because all of this is for the same information. It's all ages of actresses. None of this is other than that. It's not like some of it is ages and some of it is lucky numbers, or some of it is ages and some of it is salaries, right? It's all the same thing that's being measured, age of actress. So it all goes in list 1. Okay, so when you have all these numbers in list 1, come back and talk to me again. Pause the video till you're ready. Okay, so hopefully you have all of this data in. When I look at my calculator right now, this is what it looks like. I can see that I have down here at the bottom L137, it says. So list 1 element 37 is the blank that I am on, and that is because I had 36 actresses' ages in the list. So what we're going to do now is look at something that is called the 5-number summary. Before I show you how to do that on your calculator, I would like you to take notes about what the 5-number summary is. So non-shockingly, since this is called the 5-number summary, there are 5 things in it. The first thing is what's called the minimum. That's the smallest value. The last one is called the maximum. That's the largest value. Now, I know I'm going out of order, but I feel like this is logical. If you find the exact center of the minimum and the maximum, that's what's called the median. And so if you think about driving down the road when there's like a grassy area in the middle of a busier highway or other kind of road, that middle part is called the median. Median. So if you think of that median as cutting your data set in half, now imagine that you have 2 halves. If you cut each of those halves in half, that location is called a quartile. So that should sound to you like the word quarter, and that's exactly what it is. You're cutting the data into 4 equal parts. And what I mean by equal is it has about the same number of numbers in it. So there's quartile 1 on the lower half, quartile 3 on the bigger half. And then another name for the median or the middle is quartile 2. So let's take a look now at how to find that on your calculator. If you go back into the stat menu and then over to the calculate menu, you'll see something that's called one variable statistics. That's what we're going to select. The default is list 1, but if your data were in some other list, you would then type list 2 or list 3, and those are located above the 2, above the 3, above the 4, so you would need to use your second key and then whichever number list you want. But the default is always list 1, so you don't have to change anything if you're using list 1. And then when you enter that, you get this output. Now the output screen has a lot of information on it, some of which we haven't talked about yet in our class. I will point out that X with a line on top of it is actually read X bar, and that is the name for the mean or the average. So let's scroll down a little, and you'll see that the last 5 things on this screen are the 5-number summary. So this points out our youngest actress, our oldest actress. It points out that the middle of all of the actresses in terms of age, right? The middle is 35 years old, and then the middle of the lower half and the middle of the upper half are your quartiles. So that is what is called the 5-number summary. Now, we are going to be doing a lot of different visual representations of data in our stats class, and the first visual representation we're going to discuss with quantitative data takes that 5-number summary and makes a graph out of it, and the graph is called the box and whisker plot. So a box and whisker plot shows the 5-number summary in a visual way. It's really important to recognize that you need to have a number line in order to transfer it to paper. So if you were to just draw this, it's a sketch, it's not a graph. Graphs should be to scale or have a note that they are not to scale, okay? And we would prefer things to be to scale because that's much more informative. So we want to have a number line anytime we draw a box and whisker plot on paper, or if we use technology, we should have a number line with it as well to make sure that it's to scale. And remember that 25% of the data is in each of the 4 sections of your graph. That sometimes is a little tricky, and we'll see why that is in just a minute if you don't understand the tricky comment I just made. So let's go back into our calculator and let's see how to make that graph. So the first thing I'd like us to do is to go to the y equals, and if you have anything in here at all, make sure it's cleared out. The calculator, like us, is going to do the best when it's just asked to do one thing at a time. And so it'd be better to not have other things in here that the calculator might think you're trying to graph. Then if you go into stat plot, so that's on the same key as y equals, you just have to hit the second key prior to hitting the y equals, then you're in the stat plot menu. So in the stat plot menu, I'm going to, I see right now that all of these are off. I'm going to turn one of them to on. And I do that by entering in and then switching it over to on. And then the type of graph is a box and whisker plot. There are 2 kinds of box and whisker plots in your calculator. The one that my cursor is blinking on right now is a modified box and whisker plot. We are going to talk about that in a few days from now. But this one is your standard box and whisker plot, and that is the one I'm going to select. And I'm going to select it by pushing enter. Now you notice that when I did that, these options changed. So back here, you don't have to do this part, but I just want to show you. Back here, when I was on this first picture, which is called a scatter plot, that is a 2-variable graph, so 2 different lists were shown. But when I get to my box and whisker plot, that's a 1-variable graph, okay? So I have to pick just a single list to be graphing. Now, my data is in list 1. If my data were somewhere else, like I mentioned before, you can change this, but the default is L1. Everything else looks fine to me. I'm okay with the color blue, so I'm just going to leave that. And the thing is, you need to have your calculator screen showing the right part of reality. So sort of like when you take a picture with your camera, okay, or with your phone. You need to point the lens at the right part of the world. If I want to take a picture of you over here on the right and then I aim my phone to be over here on the left, I'm not going to get a good picture of you no matter how big you smile, okay? So much like that, our graph exists in the zone of 21 to 80. I already know that because I looked at the data and because I did the 5-number summary already. So I need to make sure that my calculator is showing me the zone between 21 and 80. Now there's a really kind of cheaty way to do that, which is in the zoom menu. So if I pick zoom statistics off of this list, I can either arrow down or I can type the number 9. The calculator is going to automatically select for me. It's going to point the camera at the right thing, right? It's going to point the phone lens toward the thing I want to take the picture of. And so that does it for me. That's fantastic. Now, if you look in window, you'll see that this is what the calculator selected. It said, hey, let's start at about 15 and let's go up to about 86 because that encompasses the data. It says here that the number line is counting by ones. Now, if I don't like any of that for some reason, like let's say I think counting by ones, those tick marks were way too close together. And let's say I know I want to maybe go from 20, rounder number, not a decimal, and my graph needs to go maybe just to 85 instead of to a decimal. I can always overwrite that and then just click on graph. And I personally think this is a little cleaner looking just because this axis isn't so jumbly. When it was counting by ones, like all those tick marks are really tight together. Now the really great thing here is if I hit trace, it's going to tell me the 5-number summary. So if you want to see both a picture and the 5-number summary, you might want to make the picture first, and then off of this you can read, oh, the minimum's 21, quartile 1, median, quartile 3, see those values at the bottom of the screen, and the maximum. Okay, so what percent of actresses are in this part of the graph, this whisker part? That is between quartile 3 and the max. What percent of actresses? Hopefully you said 25%. Okay, what percent of actresses are between quartile 1 and the median? Hopefully you also said 25%. So you see, this is the thing that's confusing. This little region here contains the same amount of data, the same number of numbers, as this long part over here. So why is this long part over here so long? It's because the actresses' ages are more spread out. Okay, so if you remember back to the original data set, there were 36 actresses. Half of 36 is 18 and half of 18 is 9. So each of the 4 sections of this graph contain 9 numbers. The actresses in here are really squished together. They're very close in age. Those 9 are very close in age. Okay, you'll also notice I did not actually explicitly say this, but this box is around the quartile 1 to quartile 3. This is the middle 50%. Okay, and you can see that because there's this long tail to this side, this is what we would call being skewed to the right. If you see a longer tail on one side of the graph than the other, that's what's called being skewed. The contrasting term to that would be being symmetric, okay, and that's where everything is kind of centered and the same on both sides. This is not the same on both sides. All right, let's go back to our slides. Okay, there are 2 other graphs that I would like to discuss with you today that would be ways of showing quantitative data. This is what's called a stem and leaf plot, and it is called that, much like the box and whisker plot is such a logical name for what it looks like. This is called a stem and leaf plot because this part is what we would call the stem, and then all of the digits over here are what we would call leaves. Now, a nice thing about a stem and leaf plot is that you actually can see the full data set still. Unlike with the box and whisker plot, like once we had that made on the calculator, I don't know what the actresses' ages are anymore, right? I can only just see the graph. Whereas in the stem and leaf plot, I can see the shape of the data and I still can see the actual digits still. I can see that there's a ton of data here in the 50s. So the way that this is read is within this line that I'm on right now, the 0 here means 50 or 50, then 51, 51, 52, 53, 53, 53, 54, and so on. So I'm using this stem with each of the leaves, okay? So a few attributes. First of all, there needs to be a key. So 2 with a 7 in this graph means 27. You might have a different stem and leaf plot where 2 with a 7 means 2.7, or 2 with a 7 means 2,700,000, right? So it could be a bunch of different things. The idea is that you have 2 digits and those 2 digits represent something. Another idea here that I need to point out is how the digits are aligned. So you see how all of these digits are aligned vertically. Same thing here, same thing here. Now this is easier to do when you're typing, but if you're writing one of these by hand, watch that you don't like swoosh in on digits like 1 that don't take up a lot of space and then make the 8s or other things that take up more space. Like, don't let them take up more space. Every digit should take up the same amount of space. So everything is vertically aligned. And that is because you want to be able to see the shape of the distribution. If you kind of turn your head to the right, you can see here, okay, this graph has a big peak here. And it's not quite symmetric, but it also is not severely skewed, right? There's a little bit more of a tail maybe going this way, but it helps you to just kind of see the shape of the graph, okay, overall. And if there were any digits that didn't have an entry, such as, let's say this 32 hadn't been there, you would just have an open space right here, but you would still include the 30, because if you started counting from the 20s, you have to keep counting the consecutive digits until you're done. So even if there's a gap in your data, a gap in data is like having a rest in music, right? If you have a space in the music, that helps. That's part of the music, right? It's not just the notes, it's also the rests. So I hope that's an analogy that helps at least some of you. So what I'd like you to do now is to pause the video and take this set of data. So this is quantitative data. These are scores that some fictitious students got on a biology midterm. And I'd like you to make a stem and leaf plot for this data. So pause the video and make your own stem and leaf plot for this data set. Okay, I hope you did that on your own, gave it a try. This is my copy of my stem and leaf plot. So you can see that I used the stems 6, 7, 8, and 9. I had a key that told my reader that the 6 with the 7 meant 67. I wouldn't have had to use that element. I could have used 9 with 0 equals 90 or any other example from the graph. Notice how I have vertical alignment of my digits. As best as my handwriting would allow. One thing I did forget to mention previously was that these digits go in order. So 80 comes before 82, comes before 83, comes before 85. That was definitely present in the last graph, but I apologize that I did not say it on the previous slide. So put those leaves in order, right? And so you have your stem, that's the part in blue. You have your leaves, and the leaves are in sequential order with good spacing, okay? The last kind of graph that I would like to discuss is what's called a dot plot. And a dot plot, I think, is sometimes like an easier kind of graph to understand. Now, the disadvantage of a dot plot is that if you have a large amount of data, making a dot plot by hand or even by use of technology is kind of a hassle. So similarly to the stem and leaf plot, the stem and leaf plot is not a great kind of graph if your data set is very large. Stem and leaf plot is not a great choice if your data is very spread out, like some of the things are, you know, tiny little decimal numbers and some of your numbers are really huge. Like if the magnitude of your data really varies, a stem and leaf plot is not your guy, not the best choice for displaying your data. A dot plot is going to be a good choice for data that isn't like not a huge data set, and you still can, you know, kind of just conceive of it in a way that you can put things on a number line easily. So for example, in this data, we asked some students, how many minutes does it take you to eat breakfast? And the span of numbers was just 0 to 12. 0 meant they didn't eat breakfast at all. 1 minute was like some kids who just ate like a granola bar and like just wolfed that down in the hallway. So it's not a huge span, and no one is going to be saying like decimal values, right? No one's going to say, oh, it takes me 5.68 minutes to eat breakfast. almost everyone's going to give us a whole number here, which makes a good candidate for a dot plot. So not that much data. Numbers are simple in some sense of the word, and not really varying in terms of magnitude. Like if I had from 0 to 6 million, I might not want to have that as a number line unless I just had like 1 million, 2 million, 3 million, or something like that, right? So you have to kind of look at what kind of values you have in your data set to see if a dot plot would be good. And then all you do is you stack dots. And so I can see here there were 6 students who did not eat breakfast at all. And I can see that the most common answer was 10 because there's 1, 2, 3, 4, 5, 6, 7. 7 people who answered 10. I do need to keep consistent spacing across. So much like the stem and leaf plot, I want to watch my spacing because if I were to put these dots like really, really squished together, and then these dots over here really spread out, I might have 2 stacks that look like they're the same height, but they actually are not. So watch your spacing. But that's all about the dot plot. So there is an exit slip for this lesson on Schoology. So now that you have your notes, what I'd like you to do is to go take the exit slip. In the exit slip, I ask you to make a box and whisker plot and take a picture of the result. I ask you to make a stem and leaf plot and take a picture of your result. I ask you to make a dot plot and also take a picture of your result. So you will submit those 3 photos. There's also a question where you type in what quantitative data is, which is what we were talking about today, as compared with categorical data. That's what we talked about in the lesson that came right before this one. So if you're not ready to do those 4 things, I suggest that you go back in the video and listen again, or send me a question. But when you're ready to do it, go ahead and do the exit slip. Thank you so much.